So I'll do 16 because it's similar to 15. Okay, I'll show you how to do 16 and you can do 15 for the homework. All right, let me go to the board and I'm gonna write this down. So the question is to solve. The question is solve each equation. So 2, 3x. 2, 3x equals 6 over 5x plus 8, 45. So please, if you have your speaker on, make sure you turn it off and turn it down and use headphones if possible. Okay, so I'm gonna write this down on the discussion board, the whiteboard. I want everybody's attention. Please see how this is done. All right, so this is again 7.4, question number 16. It says solve. Okay, so this is an equation with fractions. We've done something like this in the beginning of the semester, but we didn't have x here. It was here up. It was up in the numerator. It was not in the denominator. Also this x, so we had all the x's up, not down. That's why we call these rational equations, because of the x is in the denominator. But the way we solve these is similar to the way we solve the linear equations in the beginning of the semester when the x was here. So the first thing you want to find is the LCD. Okay, you want to make all these the same. So to make all these the same, what do you think we're going to do to make these the same? So we need to find the LCD for 3, 5, and 45. What's the LCD, or the common denominator, for 3, 5, and 45?
15.
15 would be for 3 and 5, but then we have another one. So we got to find an LCD for all of them. So we're going to find an LCD for 3, 5, and 45.
45.
That's right. So the LCD would be 45. So 3, 5, and 45, the LCD would be 45. Okay, because we want to make all of them the same. And then we have x here, x here. We don't want x here. They all must have the same thing. So you look at the variable of x to the first power. We have x to the first power. So the LCD basically would be x to the lowest power. X to the lowest power happens to be the same, so we're just going to take x to the first. If you have x2 and x3 and some other power, you always take the x with the lower power. Okay, for the LCD, not for the GCF or the greatest common factor. So you have 3, 5, and 45. The LCD is that. Then you go to the variables. You take the variable with the lower power. In this case, it's the same, so we're going to take x1. That's the first step, find the LCD. Then we're going to multiply the whole equation by the LCD. Okay, so we're going to take this equation and I will just times that by this LCD. I'm going to put it here, 45. X, also here, 45x. Then also next to the last one. Okay, so again, you got to find the LCD. First, start with the numbers. You have 3, 5, and 45. The LCD, or the common denominator for those, is 45. Then, since we have x here, it has to be also part of the denominator. If you have access to different powers, you take the lower one, or the lowest. Otherwise, These are the same, you took the same thing. Once you find the LCD, just write it next to each fraction. Just like that. So write it next to each fraction, as we did. Now we're going to reduce, we're going to simplify all these fractions, and you'll see that the fractions will go away. We're going to end up with a simple first degree equation without fractions. Okay, so let's see how to do that. Starting with the first one. So you start with 45 divided by 3, that will be 45 by 3.
15.
That will be 15, that's right. We're going to reduce all these fractions. Before multiplying, you want to reduce first, cancel out before multiplying, because that will make the fractions go away. So that's 15. And then what happens to the x and the x?
They cancel out.
That's right. I'm talking to everybody, not just Shania. So the x by x cancel out. Then we have these two left times 2. Then we'll move on to the next fraction. Again, do not multiply yet. Instead, we're going to reduce. Same thing. So we have 45 by 5. That would be
9.
9.
Very good. And then x by x cancel out, right? These two cancel out. And finally, what's left is times 6 plus, move on to the third one. Again, before multiplying, we want to cancel out to cancel the fraction. 45 and 45 cancel out. Does the x cancel out?
No.
That's right, it stays here because we don't have x here. So it's going to be 8 and x left. As you can see, that's a much easier equation, first degree equation without fractions. Now we can multiply. You can actually multiply and solve. 15 times 2, that would be 30. And 9 times 6. What is 9 times 6?
54.
That's right. Plus 8 times x, obviously 8x. And you solve like you normally do. What do you do after? What is the next step?
Subtract 54 on both sides.
That's right. We're going to cancel. So we want to cancel 54 and then cancel 8 to isolate the x. That cancels. You have 8x. And 30 take away negative 50, or take away 54, that would be negative 24. What is the final step? To get the x by itself?
Divide 8 on both sides.
So I'm going to divide everything by 8. So x will be negative 24 by 3 will be negative
3.
by 8, negative
3.
3. And that's basically your solution. So remember 2 main steps. So you want to find LCD first and multiply everything by the LCD. Just put the LCD next to each fraction and reduce. Okay? Reduce. That way, all the fractions cancel out. Okay, so when you reduce first, you end up with a much simpler equation without fractions, and you can easily solve that. If it's a first degree, you solve it this way. If it's a second degree, you may want to solve it by factoring or using the formula or some other method, depending on the question. Okay, does it make sense to everybody?
So you will multiply the numerator with the LCD and then divide at the bottom at the denominator?
Yes, so just put the LCD next to each fraction, then reduce. So 45 by 45 cancel out, x stays, and so on. Just to reduce before actually multiplying. Okay? You multiply after we cancel all the fractions. That's what you multiply as we did here in this step. Okay, so that's how you solve equations with fractions. Same way as we did before with first degree equations. Find the LCD, cancel the fractions, and solve.
Okay, thank you.
All right. Make sense to everybody?
Yes.
Everyone, please let me know if something is not clear. And again, when you do your homework, when you study, write down any difficult questions for me. So when we meet here, I go over them. But before you do the homework, make sure you go over the resources available in the ebook and the course resources section. There's plenty of videos, animations, PowerPoints explaining the material. So you want to go over that first before you do the homework. And as you do the homework, again, write down any difficult questions that you don't understand, so we can go over them here during our Zoom meetings. All right, so let's take the questions, everybody.
I have a question.
Sure.
Same chapter, it's 23.
Same unit, question
Yeah,
23, right?
unit.
Okay. Let me switch. All right, so you're asking about this one here, right? 23. You guys see this?
Yes.
Okay, so she's asking about 23. So 22 and 24 are similar. So instead of 23, let's do 22. Okay, I'm gonna do 22 on the board. The same question here, solve each equation. Only difference, the one we just did had 3 fractions, 1, 2, 3. This one has only 2 fractions. So there's 2 ways we can do this one or this one. We can do the same way we just did, find the LCD. Same way, write the LCD next to each fraction and cancel out. Or there's a second way to do this, 22, since it has 2 fractions. What do you think we can do here with this one, with 22?
You cross multiply.
That's right. So if you have only 2 fractions, you can just cross multiply. You don't have to find the LCD. You can still do the LCD like here if you want, but it's probably easier to just go ahead and cross multiply. Let's do that. Let me open the whiteboard and we're gonna go over 22. We're gonna disconnect in 10 minutes. Please rejoin the meeting right away using the same link that I sent you. It's also on the Blackboard. All right, so this was, it's gonna be 23. And the question is 5x. Okay, so if you have 2 fractions only, an equation with 2 fractions, you wanna cross multiply. Or if you want, you can find the LCD for these 2, then times both by the LCD, but it's easier to cross multiply. So we're gonna take this, 5x minus 8. We're gonna multiply that by x plus 3. And x plus 2 times 5x minus 1. Okay, and what do we do next?
Distribute.
That's right. We're going to distribute this side, combine like terms, and do the same thing on this side. So we're going to simplify each side first. So we're going to go like this, then like that. 5x times x, be 5x squared. And 5x times 3 will be 10x.
15.
Okay, then same thing with the negative 8. Negative 8 times x, negative 8x. Negative 8 times 3,
Negative 24.
right? Negative 24. Then we go do the same thing to the other side. So x times 5x will be
Squared.
5x squared. X times negative 1 is negative x. Positive 2 times 5x, positive 10x. Positive 2 times negative 1 is negative 2. Good, so we distribute everything, add the powers, be careful with the signs. Now we're going to combine like terms. So what combines here? Based on combine, we're going to combine these two. So 5x squared, so we're going to combine these two here. Positive 15x minus 8x will be positive 7x minus 24. And here, what we combine? I combine these two here, so 5x squared. So negative 1x plus 10 would be
9x.
that's right, positive 9x and minus 2. So that's so far so good. We simplified everything. Now we need to cancel out. We need to move everything to one side because it's a second degree equation. Okay, we need to move everything to one side. So it'll be all of these will move over and the sign will change. Okay, all these signs, we're going to move them across and they will change. But this one's going to stay the same for now. Let's leave these here, 5x squared plus 7x. So 5x squared moves over, turns into what?
Minus 5x.
That's right, negative 5x squared. Then positive 9 to the other side with the equal sign becomes negative 9x. Negative 2 becomes positive 2. What's left on this side if we moved everything?
0.
That's right, just 0. Everybody else, please, I want to hear from you. Okay, Kala, Elizabeth, Gang, Xenia, Lauren, Paras, Ruby, Shania. I hear from you, that's good. Now, let's simplify here. So what happens to this side? Start with the 5x to the second. What happens to 5x to the second and negative 5x to the second?
Just x or 0.
These actually cancel out. Okay, 5x to the second minus itself cancels out, and then combine these two.
So it's cancel.
And also combine these two. So what's 7x minus 9x?
Minus 2x.
Negative
Minus-
2x.
That's right, minus 2x. And you have negative 24 plus 2.
Negative 22.
That's right, negative 22 and 0. So you now keep solving. What happens next? Can I add?
Oh, it
22 goes on the right.
That's right, can I add 22? Add 22. That cancels, so negative 2x equals 22. What else? What do we do after that?
Divide.
That's right, going to divide by negative 2. Divide by negative 2. Finally, x is 22 by negative 2 will be
11.
negative.
Negative 11.
And that's it. Okay, so again, let's recap. We have only two fractions in an equation. Just cross multiply, or you can still find the LCD and multiply both by the LCD and cancel out like we did here. It will work, but probably easier to just cross multiply. And once you cross multiply, distribute both sides, combine like terms on both sides. And after that, if it's a second degree equation, you want to move all to one side to write it in standard form. So move all the terms to one side. Make sure you change the sign when you move something to the other side with equal sign. Combine like terms again and solve. X is negative 11. Makes sense to everybody?
Yes.
Yes, but I have a question still on that.
Okay.
Because in the book we talk about finding the solution set and verifying whether it's a true statement or not.
Okay, I know what you mean. All right, so it's a good question. So after you solve, so after you solve the equation, this might not be a solution, even though we didn't make a mistake. So this might not be a solution. So always after you solve, you're gonna check your solution. What do you mean by check is, look at this solution and see if it's defined. So each fraction here has x in the denominator. As we know, x can't be 0, or the denominator can't be 0. So for example, for the first fraction, we don't want to have 0 here. So x can't be what value if you don't want to end up with 0 in the denominator? X can't be?
X minus 2.
That's right, x cannot be equal to -2. And over here, x cannot be,
-3.
we don't want 0 here because we can't divide by 0. So x can't be -3. So these values are undefined. If you solve and your solution here is one of these, then it's not a valid solution. You say no solution. But after you solve, you got to check these against these values. Is -11 fine? Is that a good solution, -11?
Yes.
Yes.
Yes, as long as it's not one of these, then it's fine. So this is valid. Okay, so whenever you have the x in the denominator, after you solve, you want to make sure your solution is valid. We're going to get disconnected in a second. Please rejoin the meeting and we're going to go over more questions. Okay, so again, the denominator cannot be 0. You say x plus 2 cannot be 0. Then you solve this for x. -2 minus 2. So you say x can't be -2. That's why I said here x can't be -2. And then you do the same thing for x plus 3. Because as you know, we can't divide by 0. You can't say 7, for example, divided by 0. That's undefined. This number is undefined. Division by 0 is not possible. That's why we try to avoid 0 here. So in order to avoid 0, x can't be -2